OGR point is used to implement the simple features point. It can handle 2, 3, or 4 coordinate dimensions, so the famous X, Y, Z, M coordinates. And it overrides or implements some of the methods which are defined by OGR geometry. Then OGR curve, OGR simple curve, OGR circular string. The OGR curve implements the simple features curve, which is defined as a sequence of points, so OGR points in GDAL, with subtypes of curve specifying the interpolation between points. So it also provides an iterator to the points within, and a closed curve can compute its area. The OGR curve itself is abstract, and you have to use one of the two children, which might be OGR simple curve, which is an abstract parent to OGR circular string and OGR line string. It is the real parent class because OGR curve only exists for differentiating between simple curves and compound curves, which is only exported for compatibility issues. And OGR circular string represents a circular string, which means a curve made of arc circles. The compound curve, it contains a collection of curves. It's a member of itself and the OGR curve polygon, and it is exported only because of linking issues in the API. So you have to never use it directly. It's part of the inner mechanisms of OGR. So the OGR line string is a concrete representation of a multi-vertex line, so it's a line with several sublines with angles. It implements methods defined for curves and for simple curves, and it is very useful for many non-closed data representations. So for instance, roads, networks, actually roads are a kind of network, boundaries, because in OpenStreetMap, for instance, boundaries might be decomposed into several parts. For instance, if you look at the French department's boundaries, they are separated into the boundary part between each pair of department, and then you have to append all of these parts of the boundaries for one given department to get its full boundary with more than one other department. And a line is a line string with exactly 2 points. So here is an example of line string. We create from the WKT line string 002202 minus 20 minus 3 minus 3. So it's a line string with 5 points. And we display its size, it's 5. So the line string contains 5 points. So it contains 4 sublines, segments. And we display the elements, so the vertices of the line string, which are the points 0, 0, 2, 2, 0, 2, minus 2, 0, minus 3, minus 3. Then the OGR linear ring, it implements the simple feature linear ring, which is defined by a line string, both closed and simple. So simple means it has no intersections with itself, and it's closed means that the start point and the end point are the same. So in the following examples, only C is a linear ring because B is not closed and is not simple. D is not simple but it's closed, A is simple but not closed, and C is simple and closed. OGR surface, now it implements the simple features surface. It's an abstract class which provides a method to test if a point is on the surface and a method to compute the area of the surface. Then OGR curve polygon and OGR polygon are children of surface. They represent polygons whose boundaries are linear rings and which can contain holes. So the first linear ring is the outer boundary. The next linear rings are the inner boundaries. So if you have holes in the polygon, you have more than one linear ring which defines the other boundaries. The current version of the library added the OGR curve polygon, which does not exist in simple features, for possible extensions. And for polygons whose boundaries are straight lines, you can use OGR polygon, which is more specialized. So here an example with OGR polygon. We create a polygon whose coordinates are 0, 0, 2, 0, 2, 2, 0, 2, 2, 2, 0, 0. It's a square. And a point at 1, 1. If we can create both, we display the area of the polygon, which is 4. It's a square of width 2, so it's 4. We test if the polygon contains the point, it's true, and we test if the point is in the polygon, so with the function within, it's 1 because it's true. So of course, if polygon contains the point, then the point is within the polygon. The OGR triangle, it's a subclass of the polygon with an outer boundary composed of only 3 points, which must be non-collinear, because else you do not have a triangle but a line, and has no inner boundary. It provides a constructor with 3 OGR points, and it's very useful when you associate OGR with 3D imaging, because in 3D, if you use, for instance, OpenGL, everything is decomposed into triangles to be easier to compute and project. So you can almost directly export your OGR triangles to something that the OpenGL can use efficiently. Then OGR polyhedral surface and OGR triangulated surface. They implement the simple feature polyhedral surface, which is a surface composed of several polygons, and the common parts of the boundaries must be consistent, which means they must be in opposite directions. And OGR triangulated surface is a special case of polyhedral surface composed only of triangles, which also is very useful with OpenGL or other image generating system.